Assalamualaikum and greetings to everyone. I'm going to share the presentation of an assignment of power system protection. This report and content of this is prepared by three students, which is Muhammad Azuddin, Muhammad Ilman, and Muhammad Ahmad Sazwan, to be submitted to Dr. Hendra bin Hairi. Students are given a task to design and develop of overcurrent protection of a radial distribution system as shown in the figure. To design the relay distribution system from the task, students had defined the rating on their own, such as generator rating, transformer rating, load, and any assumption used to design the relay. Next, for the suitable equipment for the circuit, we choose a current transformer, plug setting, and time multiplier setting. From the figure, we had to show that the circuit is based on three main buses with a two load. The two transmission line between bus 1 until 2 and bus 2 until bus 3. The fixed load is only in bus 2 and bus 3. Then between the bus 1 and bus 2, there is only one transformer between them. Here is the table of parameters that has been used to design an overcurrent protection of a radial distribution system, which consists generator with 230 kilowatt, 50 Hz frequency. Next, a generator is connected to step-down transformer which is from 230 kilowatt to 11 kilowatt. It is connected to three buses but only consists load in bus 2 and bus 3. Then the parameter that has been set is a current transformer ratio, which is on bus 1 is 300 ampere on primary and secondary 5 ampere. For bus 2 is 400 on primary and 5 ampere on secondary. And for bus 3 is also 400 for primary and 5 ampere for secondary. The power factor that have been used in this task is 0.95. The last parameter that have been set is short circuit current, which is 200 ampere, 2000 ampere in bus 1, 2500 ampere in bus 2, and 2700 in bus 3.
This is the simulation design of the assignment. The design is without fault. To perform the load flow simulation, the electric meter instrument is required to configure to get the data from a simulation. Based on figure, the multimeter shows the transformer's sending power is close to the receiving power and load end. The meter shows that the 55 MV transformer configuration with a 230 over 11 kV is sufficient to get the power, reactive power, and voltage. The losses and the effect of the transmission line make some differences in value. The distance between CT and relay is used for the selection of secondary current transformer. At relay 1, 2, and 3, 5M was assumed because the distance between CT and relay is less and supposed to be on the same switchboard. This is the result of the simulation. As we can see, for load 1, the value of the current is 410 amps, and for load 2, the value is 150 amps. And lastly, for the bus 2, the value of current is 520 amps. For this This is figure of design with look. With This is the simulation design with fault. Based on figure, to simulate the fault analysis, the time fault logic component is added to both loops. The fault time is set at 2 seconds and fault operation period is 8 seconds. To get maximum fault current, the type of line-to-line fault is configured. The fault type setting is ABC phase fault. This is the result of the simulation. As we can see, the value increased significantly. For loop 1, the value current is 6800 M. For loop 2, 1580 M. And for bus 2, the value is 6500 M.
To make the conclusion, the current transformer is depend on the burden of the load, the length of the cable, and the protection of the transformer. The selection of the secondary current also affect the system. In short, the project design of the overcurrent protection in a radial distribution system is not tally between the simulation part using PSCAD and the calculated part because there are some parameters that used for simulation are not considered in calculation part. That's all. Thank you.